Hi everybody, welcome back to Chem 161. Today we are going to finish section 3.2. There's really not much left. I just wanted to make sure that we spent 10 minutes on going over the details, since there are questions on this on the first exam. And then we're going to have a review session. The review session is going to be entirely, participant generated, really. I did not bring anything I did not prepare anything for the review session. It's just, if you have questions, I'm happy to answer them. I didn't get any emails for this specific class, and I didn't see anything in the Discord that hadn't been addressed, so hopefully people here have questions that they would like answered. Otherwise, we're just going to have a very short stream. Other agenda items on the screen, you could see last call for quiz number 2 and lab worksheet number 2 is today. I don't remember what class in the Discord said this, but they had a really good analogy where the deadline was, please get your assignment in tonight, and the last call is, get it in or else. That's appropriate, yeah. Get it in or else. If you don't get it in tonight, it's a 0. Get it done. All right. Let's talk real quick about the Bohr model. Again, this is where we left off last time. So we talked about how when electrons orbit a nucleus, if we make an assumption that they orbit in these energy levels, and we give them energy, they will move outward. But when they get rid of that energy by moving inward, the mechanism by which they release that energy is light. And that light will have a specific E, or energy, that correlates to how far the electron fell. Now, this diagram is a simplification of what the orbital energy levels look like. A better version of that is shown not on this screen, but on this screen here. So, in quantum mechanics, the energy levels for atoms tend to start very spread out and then cram towards each other as they get towards the top. So n equals 1 is very low down here. Then there's this huge jump to n equals 2, then n equals 3, n equals 4, on and on and on and on and on, until you reach n equals infinity. There are an infinite number of levels, and yeah, they cram together like crazy as you get towards the top. And you can kind of see this property at work when you look at the spectra. And this is kind of how we figured out, oh, this is how our energy levels look. So if I circle this region right here, then you could see that the energies for 3 to 2, which this is red. Oh my goodness. This is red. Then there's another line which is a fair bit longer. Then there's another one that's just a little longer, and then even just shorter still. So we should see a line, and then another line further down the spectrum, and then 2 lines that are closer together. And the lines should look like they're sort of compacting. Well, if we go back to hydrogen, that's exactly what we see here. So here's the 3 to 2. Here's the 4 to 2. Here's 5 to 2. And then here's 6 to 2. This one. This one right here is actually 7 to 2. I think that one's false colored because most people cannot actually see the 7 to 2. I certainly can't. I've looked at these in the detector that we have on the campus, and I've looked at various emitters that we have purchased or used. I can't see the 7 to 2. I can barely see the 6 to 2. So, if your eyes are better than mine, and there's quite a good chance that they are, it is possible to see the 7 to 2. But you can see that the lines sort of compact, and this arrangement looks like the arrangement of the energy levels that we have on the next page. So that's where this came from. Now, how do we interpret that for the helium and the barium spectrums? Well, in helium and barium, you have more electrons, and you have more protons. So the protons pull the orbitals and change their energy, and you get different results. Now, if these are the only 4 colors that hydrogen emits, red, cyan, blue, and purple, well, really those last few are just purple. Why do we only see those colors and not infinite colors if there are infinite transitions? Well, if we go back to this diagram here, if this is the visible region where you have to fall about this much, anything falling towards n equals 1 is going to be way too long. So this is too high in energy to see, and instead ends up being in the UV region. So anything falling to 1 ends up being UV. Likewise, anything falling to 3, like this, this is too low in energy to see, and it ends up being in the IR region. So there are lots and lots of transitions. It's just that almost all of them fall outside of the visible spectra. And since we can only see certain wavelengths of light, that means our eyes only detect certain energy transitions. If it's too high or too low, our eyes don't perceive it. Other creatures do perceive different wavelengths. So, for example, I think like honeybees can see in UV. There are various things that can see in the IR region. We only see in what we've defined as the visible spectrum. So that's why you only see a fixed number of lines in the line spectrum for a given element. All right. These levels are called principal quanta, which we're going to assign the variable n. After the exam, we're going to assign quantum numbers to describe electrons more effectively. This is the first number. You don't need to do anything with n other than know that, oh, n is the energy level that our electrons will sit on. And that energy level is related to our waves from before, where we said, oh, I can make 1 standing wave or 2 standing waves or 3 or whatever when I showed you that video with the guy in the slinky. So you saw n equals 1, n equals 2, n equals 3 in those. Electrons are also wave-like in nature, and thus behave like waves. So they only have specific energy levels that they can exist at. And those energy levels are n. All right, and we've already talked about how the levels get squished together, and that they range from 1 to infinity. So you can calculate the energy difference between any n transition by using the Rydberg formula that I gave you yesterday. And so we did an example with this. There's the constant. I already told you that you want to put the big number for n in the second spot and the large number in the first, or I'm sorry, the smaller of the numbers in the first spot, so that you get a positive result. So again, if you're using this formula, this should be your big N, and this should be your small n. So if you were going from, say, 4 to 3, you would put the 4 in for n2 and 3 for n1. That way you get a positive result. And then you just solve for the wavelength using the Rydberg constant. If you were curious, this H here stands for hydrogen. Every element has its own Rydberg constant. We're only going to work with hydrogen because it's really the only one that this equation works perfectly for. There is an issue when you have multiple electrons in which you have electron-electron repulsion and attraction to the nucleus, and there's too many forces at once for a simple equation to model. So we have different constants, but the error that we generate increases as we increase in atomic number. There's a different equation out there for this that uses like n squared over z squared, or z squared over n squared, or something like that. And the same issue, really. So we're only ever going to use hydrogen for this. All right, so we already did the transition from 3 to 2 yesterday. And so now that we have seen this equation and we have seen the Bohr model and understand that electrons go up and down, we excite them up somewhere, and then when they fall back down, they release light. And you can calculate that energy from the previous slide. Now, electrons do not have to necessarily go between wherever they start and wherever they finish. They can sort of cascade about. Most of the time, they fall back to their lowest energy level. But it's possible for electrons to go to any orientation they want to. So if I have something that started from, like, say, 1, and it went all the way up to, say, 7, then the next move could be 7 to 6, and then 6 to 2, and then 2 to 1. Or it could be 7 to 4, 4 to 3, 3 to 1, or whatever. Because there are so many electrons in a sample of hydrogen being like a mole of hydrogen atoms, or even like 1/100th of a mole, you still have 10 to the 20 electrons available. Some of them are going to get into the transitions like this. Oh, I didn't have one right here. So some of them are going to do this transition, which you'll see. And they're just constantly being excited and then relaxing back down. All right. And we already talked about it only works for hydrogen. So, all right. So what I want you to do is I want you to use the Rydberg equation. I'm going to write it on the screen. Is there another thing here? Let's see. That way you don't have to go back through the slides here. So I want you to use the Rydberg equation. I want you to tell me the wavelength for the transition from n equals 4 to n equals 2. What is the wavelength? And we'll go over the answer in about 5 or 6 minutes or so. And then we'll start the review session, because that's all I have today. So we've covered everything that's going to be on the exam. So I'll see you in a bit. Sorry, I immediately went into my email and someone asked for the constant. So let me go get that. It's like 1096776, and I never remember it. I remembered it. What do you know? Okay, so I'll write that back down over here. So RH 1096776, 10 to the 7 per meter. Now that I've written that down, I immediately don't trust it. So just looking it up again, but in the PDF this time, so I don't interrupt you. Let's see here. 1096776. Okay, cool. So we have the right constant. So 365, yeah, that's got to be too short because that would be over here. That would be UV. We wouldn't be able to see that one. Double check your answer. I'm actually getting a lot of emails from students, and by a lot I mean like 2. I'm actually answering an email from a student right now that they can't comment on the live stream, and I'm not sure why that is, because it's set to public. Like, unless you have like a very obvious like offensive username or picture, or you are typing in like HTML every time you type a comment, I don't know why that would be happening. Like, I have it set to like hold comments for review and not just purge them. So that's really strange, and I don't know why that's happening. 486 looks pretty plausible because that's at least between 400 and 700 there. That's also possible. You definitely have to sign in. So, like, I can type whatever comments I want to. Blargfarg, for example. Nobody knows what that means. But I don't understand why other people can't do that. And that's kind of one of the frustrating things about using YouTube is that, like, technically it's very easy because you just hit play and watch. But if you want to do anything past the basics, it's exponentially more complicated than it needs to be. Like, the hoops that I have to jump through for setting up the stream are... I guess it's understandable because, like, I need to have a security key so that nobody else streams to my account. It needs to point at the right server so that it knows how to get to you. But I swear, every time I hit play and it actually goes online, it feels like a small miracle. Okay, so let's go over the answer here. So I'll just leave the formula on the screen. We'll go over here. All right, so we want to do n equals 4 to n equals 2. We'll just do that. And that glitched out for some reason. All right, so I always start by writing out the formula for anything I do. And I have already got the thing solved for what I want, so I don't need to do the algebra here. So we'll just go straight to adding in the numbers. Was that the number? I forget. 10967 times. Okay, cool. There, we'll just do that. All right, so we want to go from 4 to 2. So this one's going to go first, and this one's going to go second. Now, I don't know if you knew this, but punching in this bit in your calculator is really obnoxious. So there's an easier way to do it, and here's what I do. So instead of typing 1 divided by parentheses 2 squared, I do this. And what that is if you take something to the negative 1 power, you're taking its inverse. And if you square something, that's this, right? So if you multiply those together, you just do both things. So 2 to the negative 2, if you punch that in your calculator, you should get 0.25, which is 1 divided by 4. Just to confirm that that's what's going on. And then 4 to the negative 2 would be whatever 1/16 is as a fraction. So if that saves you some key presses, then the odds of you making a mistake go down. So I find that to be really handy. Because the one thing that I screw up on in this class is I fat finger or I type something wrong in the calculator. And then I miss it and I have no idea what went wrong. And I spend like 10 minutes trying to figure it out. Because to me, the chemistry is pretty easy. Because I've done it for so long. It's the algebra that I screw up on. For you guys, both are probably equally problematic. And once you get the chemistry down, then this is really what's going to screw you up. So if I can save you the hassle of like, why is my answer making no sense? Because you didn't put a parenthesis or something in there, then that'll help you get to the chemistry mastery part much faster. So this is the result that I got. So now what I'm going to do is I'm going to take the inverse of this. So if I do this, I will get the inverse, which would be the wavelength in meters. So I'm just going to go that number to the negative 1, and I got 4.86, and I get all the sig figs here, right? 1, 2, 3, 4, 5, 6. Yeah, I do. 4862737 times 10 to the minus 7. And so in nanometers, I'm going to just approximate that to 486.3 nanometers. You would get to keep all these numbers. I'm just being lazy here. Because really all we care about is where on this spectrum that we have right here that falls. And so if I asked you, which one is 480? Well, the easiest thing to do first is to say, okay, where's the midpoint? Because that'd be 550. Because 550 would be halfway between 400 and 700. And then you'd say, okay, 480 should be sort of between those two in the middle, and this is the best candidate. So 4 to 2 should be the cyan line, and you probably already assumed that. Mostly because we just numbered them like 5 minutes ago. All right. Your question on the exam is going to be me giving you 2 random numbers. I'm going to say calculate the transition from n equals 8 to n equals 3, or n equals 5 to n equals 1, and you'll have to give me the wavelength. That's pretty much it. That's the Rydberg equation. So you're definitely going to have a question about that on the exam. And if you can do this problem just with any other 2 numbers, then you're all set. You will also have other equations dealing with light, so you'll have to calculate like frequency versus wavelength using the speed of light. So know what the speed of light is, or at least have a reference handy. And then energy of a photon, we did that, so you'll have to do that too. And then just conceptual stuff. All right, so I'm going to hit this button, and we're not going to do that. That's next week, so we're just going to get rid of this here. and go straight over to here. So for the review session... Oh, what am I doing? Oops, are you sure you want to remove this? No, I'm not. I was not clicked on Photoshop. I was clicked on the broadcaster. For the review session, I will take any questions that you might have about the class for the exam. But before we do that, I do have some questions that a student sent me. All right, and you know what I can do? So let me actually open this. So I can copy and paste their questions, and then you can see the questions. Provided that my browser doesn't crash. There we go. So let's see here. Window capture 3. Boop. There we go. All right. So these are some questions that a student sent me. And I will do my best to answer them. So how long is the exam? I can actually just go look that up. Now, every time somebody asks me the question, how many questions are on the exam? I always wonder, like, what answer is the right answer? So, like, if I said there were 7,444 questions, you would get very upset with me. But if I said there's one question on the exam, or 2 questions on the exam, you would also get upset with me. So it's like, what number do I give you that's appropriate? I don't think anybody wants the answer to this question in reality. Where's exam 1? There it is. Okay, build. Yeah, you can't actually see what I'm doing. I'm playing around in the exam here. All right, how many questions do I have? 34. So we'll add that right there. And I'll just highlight this in like a color here. So I'll be in blue. So 34 questions. All right, so there are 34 questions. Are the exam questions going to mirror the questions on the quiz, or are there going to be some curveballs in there? A little of column A and a little of column B. Mostly column A. So if you have studied the quiz questions and know where you went wrong, I draw from similar pools, but they're not identical. Now, the chance that you can get the same question that you got on the quiz is non-zero. So there is a possibility you will see questions that you've already seen before, but the vast majority of you will see new questions, because the odds of that happening are just like, they're in like the 1 in 20 range. So roll a d20. If you get a 20, it's the same question, right? Like, if you've played Dungeons and Dragons, you don't roll 20s very often, as much as you want to. I do also add in extra questions that sometimes I have a question that everybody gets, because I feel like it's particularly challenging or useful or something like that. So hopefully that answers your question. There are not that many curveballs, but don't expect 0 curveballs, I guess I should say. So when is the exam? All day Friday from midnight to 11:59 p.m. I don't know. Sorry, I type in military time. "24-hour time" is just... it's programmed into my brain. I can even be talking about normal time, and I will just immediately translate. Can you go through some of the problems that might be on the exam? Yeah, I'm totally capable of doing that. That's what today's for, right? However, you have to provide those questions for me. I can't just grab them off of the exam for you, because that would be a little bit too easy. So if you have questions about like quiz questions, today's a great chance to do that. So will you have to submit written work for the exam? No, there's no way for me to grade it. So you do not have to worry about writing any work out and then uploading that. That's not something that I deal with, because it's more or less impossible. Does the rest of the world use 24-hour time? I don't know. I feel like 12-hour time is pretty popular because I see a lot of clocks over there on like Europe, like Big Ben, that are all 12-hour time. But yeah, I don't know about that. Will you curve the grade according to class score? So grades are curved at the end of the quarter. To a small extent. What you all know as curving is actually bad, believe it or not. You do not want me to curve the exam because generally speaking, most people do well, and curving means that I set the average to a C. So if y'all do well and get like 64 out of 75 as the average, that becomes a C. You don't want me to curve the class. So what I do is not really called curving. Like I apply a small percentage of points to everyone's score at the end, and I just raise scores up. Something that I do want to note here in this category, or for this question, is that the exam is out of 83. And what that means is that if you get a perfect score, you get extra points. And in my history of teaching this class online, I would say that a small subset, like 10% or so, probably get extra credit. So they get a score above 75. So, in other words, I give you more questions than there are points. So if you don't finish the exam and you leave like 3 questions off, you could still get 75. Or if you just don't know the answer to one and you hit skip, and because you can't backtrack, you're not screwed out of too many points. Do you have some tips for the exam? We more or less went over these, but review the textbook problems and the quiz problems. Since the exam problems are similar to those in nature. And then we'll be able to go back to questions we've already answered on the exam. So, oops, for some reason my formatting broke there. So, no backtracking. Same as exam. All right. Other questions that popped up. So, are you allowed to work with other students on the exam together? So, you are technically allowed to do that. However, I don't know if I can recommend it because what will happen is your exam will be completely randomized from your friends. And so, if your question number 1 is about calculating atomic weight from the periodic table, and your friends is calculating the wavelength in nanometers of a photon of light from this transition, you're both going to be spending your own time doing your own problems, and you doing your problem and your partner doing their problem isn't really going to help each other. So, like, nothing you're doing in your problem will help your partner. And then when you do see that question come up in your pool, so you will eventually get a wavelength question, unless your partner's notes are super, super organized and you have like all the space ever to like, oh, there's the work I did. You're going to be spending time looking over all of your old work, looking for your partner's work, and that's going to waste your time. So remember, time is the enemy. So I would recommend like going into the exam knowing what you need to do and doing it entirely on your own. But if there was another person that had questions and you could quickly answer them, I'm not going to tell you, nope, no talking to other people, because already you have enough of a time constraint. Do you get 2 attempts for the exam? Yes, you do. So you get the same number of attempts as you do for anything. That's to mitigate the possibility of technical issue. So if you are taking the exam and the power goes out, or if you're taking the exam and your cat turns off the computer. My cat has turned off my computer by jumping on it before. Or if something like weird happens, you can then take the exam again. You should probably still email me and ask me like, hey, this happened, is there anything I can do about it? And depending on the nature of the circumstance, I will say yes or no. Unfortunately, in most cases, the answer is no. So, like, if your cat jumps on your computer, then yeah, the answer is no, because I can't ascertain that. All I can see is that, oh, at this time you just stopped taking the exam, and that could be for any number of reasons. Can you talk about why you disable backtracking? Yes, so I purposely make the exam accessible to you in a way that other instructors would call cheatable, I guess is the best word that I could say. It's very easy to do what other instructors would call cheating. So, in other words, you can look up stuff on the internet, you can ask other people for help, you could, in theory, get somebody else to take your exam, etc. So, in order to mitigate that and get an accurate, or at least more accurate assessment of your knowledge, I have to put roadblocks in the way. If I gave you infinite time and just left the exam open forever, most of you would get 83, and I wouldn't learn whether students actually knew the material or not. So the obstructions that I put in the way are strictly to make it frustrating to use those resources that are not your brain. So it's like, I know that you're going to talk to each other about the exam. What was the answer to that Monty problem where with the gold in the chest? Like, I don't know how to do that. Can someone show me? You're going to do that during the exam. There's nothing I can do to stop you. I recognize that. But what I can do to at least slow you down is restrict your ability to maneuver through the exam. I realize it's kind of frustrating that, like, oh man, now I know how to do that, but I can't go back to the question, or I don't know how to do this and I don't want to spend 10 minutes looking it up. And the advice that I really have to deal with that situation is, one, know how to do all the problems ahead of time, which is what I'm trying to get you to do to demonstrate your mastery. Or two, take the exam a second time and be prepared for it when it comes up again, if it comes up again. So it's not the best answer and it's not the best solution that I've come up with, but what I can say is that at the end of the quarter, when I look at all the exam scores, they feel more representative of how the class is doing on a whole. So like they're more consistent. So I don't have quiz scores that are very low and then exam scores that are all 99. I have exam and quiz scores that sort of correlate with each other. Like students that do average on the quizzes do fairly average on the exams, usually slightly better. The A students still get A's. Like stuff correlates is what I'm saying. So like it makes sense what numbers I see. So I feel like what I have set up is working despite the fact that students don't like it. And I mean, to that I just kind of had to say tough. Because there are a lot of things in life that you're not going to like, and life is not set up for my convenience or yours. I'm happy to talk about any methodology that I have for any of this, because I realize that a lot of people think that, like, why does Wes do this? It's so fucking stupid. And my response to most of those questions is, yeah, I agree, but consider this. And I'm happy to talk about that at length. No, I totally understand from your perspective. Like, this is stupid. Why can't I backtrack? I made a typo or something like that. And no, I totally agree that it is stupid to some extent. I wish that I could just like do something else. And if I was in person in class, like, yeah, I would absolutely let you backtrack. You don't turn in each page as you do it. Like, that's stupid. Unfortunately, with Canvas, I sort of had to redo everything that I do. So this is the most fair solution that I have come up with. I'm always open to ideas. However, I am very able to recognize bias from student ideas, because inevitably, if I solicit ideas from you, they're going to be things that give you an advantage, or at least you specifically compared to other students in the class, and that I can't do. I have to make it fair for everybody. I have to try and make it equitable. What is the exam on? Let's type that out. So the exam is on chapters 1, 2, 6, and then sections 3.1 and 3.2. So everything. Ooh, excuse me. Everything we did up to today, I went over the Rydberg equation just in a little more detail because I wanted to make sure people understood it. We had to rush it at the end there. There is a Rydberg equation formula on the exam, but there's nothing past 3.2 on the exam. You have already had a quiz for chapters 1 and 2, and I believe the quiz for chapter 6 is up. Quiz number 1 might not actually be unlocked. Let me go look or not quiz number 1, but quiz number 2. Let me go through and look at that to make sure that that is a thing. I don't have a button to manually or to unlock stuff, so I had to dig into the settings. Yeah, quiz number 2 isn't unlocked, so it's unlocked now if you're in section A. And then I'll do it for section B and S here, or C, I guess, but I have to do this manually every time, and it takes like 20 button presses, so I never remember to do it. Alright, that should be section B. And of course, because there are 3 sections of 161, I had to do this 3 times, so. Because they won't let me consolidate this into one class for FERPA. Which is obnoxious, but what can you do? Okay, so quiz 2 should now be visible, like all the answers and all. I should look at your scores. Are scores published? Wow, is that right? Hold on. Oh, the quiz isn't. The quiz is due tonight. Oh, okay, well now I gotta go back and lock these again. Crap. No, I went to look at grades, and like 4 people had taken the quiz, and I was like, what? That doesn't make any sense. Okay. Yeah, I need to lock these tonight and not right now. So if you were taking the quiz at this instant, you might have seen your answers. But that seems incredibly unlikely. So yeah, it's right here on my own screen. I can see it right there. Last call for quiz 2 tonight. I went into the quiz scores and I was like, why did only 4 people take the quiz? That seems really weird. Okay, so those should all be locked again. You might be able to see your score at some point. Whatever, right? Okay, did I get everything? Okay. Look at me screwing everything up. Good job, me. Okay. Anybody have any questions about, like, content or material for the class? Oh, no! All the things are falling down. What I can do is... Let's see here. I don't know where my phone went. I could go find that, though. What we can do is I could just put this on the screen here. We can take a break, because we're about at that time. But in the chat here, if you have any questions you'd like to go over after the break, let me know, and then we'll do that. And then if there isn't anything posted after the break, we'll just call it a day. So yeah, so I'll start the timer, and we'll get this going here. And I'll start the music, and I'll be back in 10 minutes. So see you then. wind the music down. Let's see here. There is someone here that would like to wish you good luck on your exams. Say hi. Say hi. Good luck. Say meow. Maya came to visit. She says, good luck on your exams, and pet me, I am soft. I will do the second part for you. If I can reach her, Maya, come back. She's going under the desk, and I can't quite reach her. So, let's see here. So, I don't really have any questions in the chat other than, like, this theoretical question. So, a positively charged hydrogen atom, no electrons, can't emit light at all. So, a positively charged hydrogen atom without electrons is just a proton, actually. And protons don't emit light because they have transitions, necessarily. I'm trying to think of what protons would do that would make light. So protons actually float around in solution all the time. They're called acids. But in particular, like, protons fired from, say, like, the sun would collide with the Earth's magnetic field, and that you get aurora borealis from the impact. But that's sort of beyond my ability to answer, I think. Like, if I had to speculate, I would say, okay, charged particle bounces into Earth's magnetic field. Energy is released from some interaction, and the effect is the northern lights. But yeah, a positively charged hydrogen is just a proton, for what it's worth. So it cannot emit light from this mechanism of an electron transitioning up and down, because there's nothing to transition up and down. There may be some weird mechanisms that protons follow by themselves, but that would be like, that's Large Hadron Collider sort of stuff, and I don't even know where to start with that. If anyone else has any questions, let me know. Let me check my email real quick to see if anybody sent me a question. I got an advertisement from a publishing company that I don't care about. That is somebody saying thank you. That is the EVCC Daily Digest. Now I'm just reading my email to you. Yeah, nobody sent anything, so. Alright, so last call for questions. If anybody has anything, let me know. Otherwise, we'll take the stream down. What kinds of numbers have infinite sig figs? Anything that's exact or defined. So if you look up a conversion that is metric to metric, it will have infinite sig figs. If you look up a conversion that is metric to imperial, those are two different scales measured against each other, and those will have whatever sig figs you look up. Since I am telling you on the exams, like, report your answer to X number of sig figs, 3 or 4, generally speaking, if you aren't sure whether something is exact or not, just report your, or use your conversion to at least 4 sig figs, and you'll be fine. Things that you should definitely watch out for, though. So if you have like something like this, Remember that ones are always exact and have infinite sig figs? I know a lot of people get confused with that because they see the 1 by itself and they're like, oh, there's just one digit there. So all my answers become 1 sig fig, which is false. That is not what happens. So anytime you see a 1, it's exact. So the same is true if I did like 1 mile is 1.609 kilometers. What this is saying is that in exactly 1 mile, there are approximately this many kilometers. So that conversion as written, the bottom number has, oops, you can't see that because, there we go. Well, actually, no. No. Sorry. I do want it to stay on the screen like what the chapters are. There we go. So whenever you see ones in conversions, ignore them for sig figs. They're the exact part of the conversion. The other thing is measured against it and is approximate. How far into section 3.1 and 3.2? The entirety of those two sections is fair game. So, now if we didn't do it in lecture, odds are I'm not going to have you do that on the exam. So, like, if there's a question asking you to calculate a number of photons, probably not going to come up on the exam. If you have a question that asks you to calculate the number of photons and you want me to do it, put it in the chat and I can do it. If you have like a question about it or are curious what the answer is or whatever. Photons are actually just like counting atoms. So you're just going to multiply by Avogadro's number or something like that. Yeah, you can put it in Discord too. I gotta find the Discord. There we go, 161. Questions. Oh, and somebody actually messaged me. So somebody asked on Discord, will the question specify sig figs and would you like us to write the units on the answers? Only if the question asks you to write units. Otherwise, just write a number. And most questions should specify sig figs. Yeah, go ahead and paste it in there. I won't put it on air, but I will copy and paste it from... Actually, if you have it as a picture, I can then paste the picture onto Photoshop. Yeah, there we go. Okay. So you gave me like 5 questions. Which one of these did you intend? Oh, probably number 10, right? Why is it asking that question? So that question is not something that you can answer in this chapter because we have not learned how to do heat capacity. So now I see the issue here. So I could show you the answer. However, you won't like the answer, unfortunately. So, So hold on just a second here. Paste. That didn't work. Why didn't that work? Okay. Yeah, I can't paste that into here for some reason. Can I paste it in here? That sort of worked. Okay. Okay, so if I go back to here, so I don't remember seeing this question, and they may have like edited the textbook. So here's the question that was asked here. Photons of infrared radiation are responsible for much of the warmth we feel when holding our hands before a fire. These photons also warm other objects. How many infrared photons with a wavelength of 1.5 times 10 to the minus 6 meters must be absorbed by water to warm a cup of water from 25 degrees Celsius to 40 degrees Celsius? So this is actually a really simple problem. Unfortunately, you can't answer this until you get to chapter like 9. When's thermo? I actually don't know this because I don't teach thermo. I don't know what chapter it's in. I can give you the answer if you're really curious, but this question will not be on your exam. I can guarantee that because you do not know about heat capacity yet. So if I could rewrite that question, what I would rewrite it to be is, what is the energy of this photon? That would be relevant for this class. So when is thermo? Yeah, chapter 9. So my suspicion about that question being there is that in the other version of this textbook, so our textbook is called Chemistry Atoms First, there is a different edition, and they probably do thermo first, and so you would already know that Q equals MCS delta T, which is why they give you the mass of water and then the delta T. Q being the energy that is absorbed. So, yeah, don't worry about that problem because you will not be asked anything remotely close to that. And I was not aware that that was there, so I apologize for that. No, there's no way. Oops, that's not the one I meant to hit. There we go. Oops. Ruining everything here. Here we go. You want to talk? Say hi. Say hi. My other cat just came in here, Cry Snake, and he just started talking. Now he's sitting there staring at me. What do you want, bud? He probably wants me to hug him. Because all my cats need hugs. All 2 of them. I don't have like 70 cats. I would love 70 cats, but I don't have space for them. So 2 is enough. Yeah, that question is definitely the curveball. That will not be on the quiz or the exam or anything like that. I was expecting a totally different question, but I'm probably thinking of a similar question that was in like in a textbook that I used to teach from that asked something along the lines of like a laser burst fires this many photons. How much energy is transferred if this is the wavelength of the photon or something like that? That was more along the lines of what I was expecting, not you stand in front of a campfire with a glass of water. How much heat or how many photons will heat the water to to lukewarm? Yeah, no, that's not something that'll happen. Other questions. Let me check the Discord again real quick. Oh, I should probably type in the Discord. So, that question won't be on the exam. It uses chapter or stuff from chapter 9. And yeah, Fortunately, I can explain why the textbook does that. It's not an answer that I like. There we go. Light with a wavelength of 614 looks orange. What is the energy per photon? What is the energy in electron volts? We do that. So the electron volt is this kind of weird unit. But really, it's just another way of writing something in joules. There we go. Okay, so we want the energy per photon of... Where'd my brush go? There we go. So this is my light, and I want the energy of it. So the energy of a photon is h times frequency, or hc over lambda, which is what we have. And so that would be 6.626 times 10 to the minus 34 joules times seconds. And then speed of light, that should be a dot there. And then we're going to times that by 1 over lambda, which would be 614.5 nanometers. So this goes away, this goes away. These units don't cancel out, so I'm going to have to multiply by another term over here to get my nanometers and meters to cancel out. So 1 nanometer is 10 to the minus 9 meters. So those 4 terms multiplied together divided by 614.5 times 10 to the minus 9. And so when I put all this in the calculator, the energy I get is 3.23 times 10 to the minus 19 joules. So that's the energy in joules. And then the question asks you, what's the energy in electron volts? Well, if I take my number here, and I multiply it by the conversion that's listed, so 1 electron volt is 1.602? Yeah. And it looks like we're going to get like 2. Yeah, 2.01. Oh, 2.02. I drew my line through the number. There you go. So we don't use electron volts in this class, but it is a common enough unit. I'm just not super familiar with them. Physicists love electron volts. They use them all the time. I just use joules because that's what's been drilled in my head, and also it's an SI unit. But it's just another unit that exists, I guess. Although looking at electron volt and then thinking about the units, it makes sense now. Does the sig fig change to 3? Yeah, it's 3 because of this number right here. However, if you used another speed of light value, because the speed of light is defined, it's like 2997928 or something like that. So if you used all those digits, then you would actually have 4 sig figs due to this and this one. And again, that's kind of part of the online class part where I just say, oh, report your answer to X sig figs, because I don't know where you're getting these constants from. And as long as you have the right number for the constant, whether it had 3 sig figs or 4 sig figs in it, I don't want that to be what ruins your answer. So, but yeah, as written, the numbers that I used, the answer has 3 sig figs because I only use 3 from speed of light. Other questions? Anything anyone's got? These are good questions. If you have other questions like these, let me know. I'm just going back and forth checking things. Let's see here. That's not a question I can answer on air. That is a scheduling thing. We can do that one. That's a good question. Okay. Yeah, I definitely do that. So let's see here. So we have 7.5. I have the wrong color. Hold on. 7.5 times 10 to the -3 moles of hemoglobin. I don't know what the abbreviation for hemoglobin is. I think it's like HB, but we'll just write that. All right. How many hemoglobin molecules is this, and what is the quantity in grams? So let's do molecules first, because in a mole of anything, there are Avogadro's number, not 60. That many molecules, right? So if I multiply those two together, that will tell me how many molecules of hemoglobin. I don't know if a molecule is the right term to give for this, because hemoglobin is a protein. I mean, I guess you could have a molecule of a protein. I'm just used to calling it a protein. So 4.5 times 10 to the 21 molecules of hemoglobin. So that would be the number of molecules. And then if I wanted the molar, the number of grams of that, I would instead do, so we'll just take the same number again. And I'd say, okay, moles I can turn into grams of hemoglobin. And the molar mass is 64,456. And the reason that it's so high is because it's a protein. Proteins have ridiculously high molar masses, because they are super, 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 super big. And hemoglobin is actually one of the simpler proteins. There you go, 480 grams of hemoglobin. So don't be intimidated by the fact that it's a ginormous number. They're trying to give you problems that are out of your usual context. If you see moles and then kilograms and then grams and then particles or whatever, those are all units that you've worked with, and then just treat them appropriately. The fact that the woman is 55 kilograms is not helpful, so try not to get tied up in the extra numbers. She could be 5 kilograms, and the answer would still be the same. She could be 500 kilograms and be the same. I don't know how she would be alive if she was 5 or 500 kilograms. Actually, I guess the 5 kilogram version could just be a child, but it says woman, so I don't know why I'm dwelling on this part of the problem. Again, it doesn't make any difference. What else do we have? Any other questions? Oops. Don't mind me, I'll just be throwing the pen on the floor. Why do I... Oh, okay. What is the mass of solute in 200 liters of a 1.556 molar solution of KBr? Yeah, we can do that too. All right, so first, what's the solute? Well, if it's a solution of KBr, that's the solute. So we need to find the mass of KBr in 200 liters. So first thing we need to do is figure out how much KBr there is in there. And I can do that by multiplying. Remember that m times v equals moles, right? So I'll take the volume and I'll multiply by the molarity. So that will give me the number of moles, which is like some 300 or so moles. But then I could just say, okay, well, in a mole of KBr, there are X number of grams KBr, and I want to say it's like 119, but that's what Lentech is for, so let's grab that. KBr 119. And then that will give me the number of grams of KBr in the sample. 200, 1.556, 119. That's a lot of grams. Holy crap. 37,032. If I'm going to do sig figs, I got to have 4. Okay, so in other words, 37.03 kilograms. Excuse me. No, don't you meow at me. He has no idea what I'm saying. What, are you lonely? Say hi to the friends. Say hi. There you go. 2-liter bottle of concentrated HCl was purchased for the lab. The solution contained this many grams of HCl. What was the molarity? So for the molarity definition, remember that molarity is moles of solute over liters of solution. So how would you solve this? Well, if you knew the number of moles of solute, which you do because you know how many grams of HCl there are, so you could figure out the number of moles. You could then divide by the volume and you'd get the molarity. So let's figure out the moles first. So that would be 868.8 grams of HCl. And then I'll turn grams into moles. 1 mole of HCl is, I think it's 36.46. Oops, HCl. Yeah. So this quantity right here, if I punch that into the calculator, would be my moles of HCl, because that's the number that's left over. And so that's 868.8 over 36.46. That's 23.8 moles per liter. But now what I'm going to do is, since that's the number of moles in parentheses, I'm just going to divide by the volume right here, which would be this. So now I will have moles per liter. So when I do this calculation, I will get a molarity. And I get 11.91 moles per liter. Other questions? I'm just ignoring cats in the meantime. Yeah, I'm ignoring you. Yeah, you're a cat. I'm not doing a good job, though. Sorry, I was answering a question in Discord in a different class because I thought it was this class, and I realized, oh, I clicked on the wrong thing. All right. So a throat spray is 1.4% by mass phenol. If this is its density, calculate the molarity. So, all right. So percent by mass is mass solute over mass of solution times 100%. And molarity is moles of solute over liters of solution. Now, in order to solve this, you're going to have to make some sort of assumption, right? Because the problem doesn't tell you how much solution you have. So here's what I'm going to do. I'm going to assume we have 1 liter. And in order to solve this, I need to basically find out all of these things. Well, if I assume 1 liter solution, I've already figured out the volume of the solution, right? Now, from that, I could use the density. And I'm going to assume exactly 1 liter of solution. Then I can use the density, which is 0.9956 grams per milliliter of solution. And then I'll just convert milliliters and liters so that these go away. So what's the mass of 1 liter of solution? It should be 0.9956 divided by 1 times 10 to the negative 3. So 995.6 grams. Okay. That's the mass of the solution. That's right here. I also know the percent mass, so that's going to tell me how much solute is in there. If I know the mass of the solute, I could turn it into moles of solute and get the molarity. So there's our plan of approach here. So 995.6, oops, hold on. So let's do percent by mass times the mass of the solution divided by 100% equals the mass of the solute, which is what we want. And so that would be, well, what's the percent mass in the problem? It's 1.40% times the mass of the solution over 100%. And so that will be this times 0.0140. And I get 13.94 grams of solute, which is phenol. And now I know the mass, I can figure out how many moles I have, and then I can figure out the molarity. So 13.49 grams of phenol, which we'll just write the formula here. So there's the turning grams into moles, and we'll go look that up on Lentech. Where's my Lentech? There it is. C6H50H, not OJ. I have orange juice in my phenol. That's not good. 94.11. All right. All of this would give me the number of moles. If I just divide that by the volume, which we said was 1 liter, we'll get the molarity. And that is 0.1433. So that's the molarity of the phenol. That's about as difficult of a problem as I could give you, really. I don't think I have anything quite that difficult on the exam. But how did I go about in solving that? So when I see a problem like that, the first thing I do is I always do this. Write all your formulas out. Like, write the actual formulas. Don't plug any numbers in, but just check off the things that you have. Because I looked at that at first and I was like, how do I solve that? And it's all about finding the way through the problem. Because you always have enough information, unless the problem is written incorrectly. But I trust that the editing in this textbook has been... they've done their due diligence, because this is actually a very good textbook for being free. And once I have written down the formulas, I'll say, okay, I know this number, I know this number, I know this number, I can assume this number. Can I get to this other number? And if you know everything, you can solve for the one missing thing. Or if you know everything else, I should say. All right. Copper iodide is added to table salt. This is news to me. I have never heard of copper iodide being added to table salt. Potassium iodide is what we usually use. All right. How many moles of copper iodide are contained in 1 pound of table salt containing 0.01% by mass? So remember that mass percent, or percent mass. I wrote solute, but I should actually just be writing it like this, I guess, because this is not a solution. Times 100%. So I know what the percentage is, and I know how much total I have. So if I want to solve for this mass, that would be mass percent times the mass total divided by 100%. And that would be the mass of copper iodide. And so the mass percent was 0.01 0.00% over 100%. So the units cancel out. Times 1 pound, which is 454 grams. So that will be some teeny tiny number. 0.01 times 454 over 100. That's times 100. Divide by 100. There we go. All right, there's my mass. I ran out of space, otherwise I would just continue the calculation there. Oh my goodness, what? All right, there's my cat. And then, now that I have this, it's asking how many moles are there. So we'll do grams copper iodide, moles copper iodide, and you probably can do this part on your own, but we'll finish it. So copper iodide, 190.45. And the answer I get is 2.38 times 10 to the minus 4 moles of copper iodide. I hate when I do that. There we go. There you go. All right, I think we have time for one more question if you have one. These are all really good practice problems. So if you know how to do these, the exam's going to feel easy. And that's sort of the intent, is like do the practice problems from the textbook because they're challenging, and then the stuff on the exam that you're timed for is not quite this difficult. It's just different, that's all. Can we over at chapter 1 quiz problem? Yeah, the quiz is closed. I can answer any questions you want about that now. If you specifically want to ask your question, you'll have to type it in, though. So, like, with your numbers. Can I go over another example of light spectrum problems? I can, I just need a problem for you to give me. Like, if you know one out of the textbook that you'd like me to do, I can absolutely do it. If you aren't sure more than that, then you'll have to be more specific, I guess, is what I'm trying to go for here. Because there are many light spectrum problems, but I don't know what you mean, I suppose. I do have to cut the stream off, though, in 5 minutes, so I can only take one more question or so. There we go, that works. Let's see. Oh, whose frequency? I was like, F. I don't understand what that means. I'm going to interpret those as 10 to the 14. Okay, so the frequency, so we'll say frequency 1 is that, and then frequency 2 is all right. So what are the wavelengths and energies of the two lines, and then what color are they? So we want these things. I want wavelength, I want energy, and then I want color. Well, wavelength and color are related. So if I know what the wavelength is, then we can just go to the color chart and then look up the color. How do I get wavelength out of this? Well, we know that C equals lambda nu, right? So, and C is a constant. And then for energy, E is Planck's constant times the frequency. So that should be easy enough to do. We can do those. So let's do the wavelength and color first. So if C equals lambda nu, then the wavelength is going to be equal to C over the frequency. So if I do this for number 1, that will be there's C, and then divide by frequency, which for number 1 was 3.45. I can't write numbers. Times 10 to the 14. Hertz, and a hertz is per second. So those go away. And then this is going to be in meters. I don't want meters. Let's just immediately turn it into nanometers. Because if we're going to land in the visible spectrum, this is going to get us a number in the visible spectrum. So 3 times 10 to the 8 divided by 3.545 times 10 to the 14 times 10 to the minus 9. That's not in the visible region. So I got 869.9 0.5, so 870 nanometers. Which is not visible. That's infrared. You wouldn't be able to see that. Did I type something in wrong? Three times 10 to the 8. Are you sure it's 3.45 times 10 to the 14 hertz? Because that's definitely the answer. Yeah, I got 869. But we can do that for the second one. And that's going to be the same thing. And its frequency is 6.53. That's the number the book has. Okay, well, this is IR. This is not visible. Which is rude. What color is the line? It is invisible colored. You cannot see it. All right. So, what wavelength will this be? This will be a smaller wavelength, and it will fall in the visible range probably. So 3E8 divided by 3. Oops, that's the wrong one. 6.53 times 10 to the 14 times 1 times 10 to the minus 9. 459. This one's visible. So what is 459? This is like yellow-green. Actually, this is more like yellow, I think. No, wait, hold on. Sorry, wrong direction. 459 is like dark blue. Okay, so there's our wavelengths. And then to find our energy for these, we would just multiply each of these numbers by Planck's constant. So we'll just do that up here. And so the energy per photon for this one... Oops, I missed a minus sign there. And I got 2.29 times 10 to the minus 19 joules. If you're working with photons of light, this is a very common thing that you see, times 10 to the minus 19 joules. So you'll just kind of get used to that. I'm going to erase this part because I need the space here. So the energy of photon 2 would be the same process. Times the other frequency. And I get 4.33 times 10 to the minus 19 joules. There you go. All right, so that was a problem that involved you taking a frequency and then turning it into a wavelength or an energy. Frequency is pretty universal because it's in both formulas. You can see it right here. So if you see that you have this, remember that you can go in either direction for it to get to either lambda or energy from there. All right. I hope that helped. Let me know if you have any other questions on the Discord or email. The exam, I'm gonna go program in the exam later tonight to It'll send out an email that says exam created, but it won't be available. On Friday, the exam will open unless you have made arrangements to change the day earlier or later. That's fine. It's open for 24 hours, and you get to that 24-hour period to take it both times. Once the time has elapsed, the next day on Saturday, I can't do anything because some people are taking the exam on Saturday. But on Sunday, I will hit a button and post all the scores. The answers will not be released for the exams. I don't release exam answers. But you will get your scores then. All right. So, again, let me know if you have any questions. And best of luck on the exam. Have a great weekend. See you next week for more quantum mechanics.